Hello, my name is Xiangci Li. I'm a PhD candidate at UT Dallas. I'm excited to present my work done at Tencent AI Lab here at LREC-COLING 2024. Our topic is a knowledge plug-and-play testbed for open domain dialogue generation. Knowledge-based open domain dialogue generation aims to build systems that talk to humans on various domains and mine support knowledge. The wizard of Wikipedia work has a wizard and apprentice speaking to each other. The wizard can access to knowledge sources, for example, Wikipedia in this case, and the apprentice does not access to the knowledge source. Each wizard utterance is annotated with knowledge sentence, and there are two tasks involved: dialogue knowledge selection and dialogue response generation. In this work, we work on multi-source open domain dialogue generation. Specifically, we wonder how does knowledge from multiple sources interact with each other, and what if new knowledge is added after the model is trained. Prior works either only use single source knowledge for dialogue generation, for example, Wizard of Wikipedia is the case, or use silver multi-source dataset, which is unable to evaluate the knowledge selection performance. This motivates us to create a dataset of multi-source Wizard of Wikipedia, shortened as Miss Wow dataset. Here's an example of Miss Wow dataset. Given the one of the response at the top, there are some knowledge sentences from the original Wizard of Wikipedia dataset. We divide the knowledge in Wizard of Wikipedia into 4 non-overlapping partitions of knowledge sources. Specifically, we replace the knowledge sentences in Wizard of Wikipedia with knowledge tuples from different sources: OPIEC, semantic frame, and Wikidata. If there are any remaining sentences not replaced by the 3 knowledge sources, then these knowledge sentences form the last type of knowledge source, Wikipedia. Again, we deduplicate the knowledge tuples such that the knowledge sources are all non-overlapping partitions. Meanwhile, we retain the utterance level knowledge annotation provided by Wizard of Wikipedia. Therefore, our Miss Wow dataset is a multi-source dialogue dataset with utterance level knowledge annotations. Here's the statistics of our Miss Wow dataset. Since it's derived from Wizard of Wikipedia dataset, the number of utterances are the same. What's different is the number of support knowledge from different sources. OPIEC consists of most of the knowledge tuples, while semantic frame has the smallest proportion of knowledge tuples. Table 3 shows that knowledge tuples from different knowledge sources are very different. OPIEC has the most number of elements. On average, semantic frame has the most number of words because it's simply cutting the sentences into different semantic frames, while Wikidata tuples are strict triplets, that's the shortest. We use Miss Wow for dialogue knowledge plug-and-play, which aims to test an already trained dialogue model using new support knowledge from previously unseen sources in zero-shot fashion. As we mentioned before, there are 2 tasks involved. We fine-tune Roberta base for knowledge selection and BART base for response generation. Let me explain how we did dialogue knowledge plug-and-play. Specifically, we ablate knowledge source one by one during the training phase and test the model performance with the intact knowledge sources. Table 4 is the knowledge selection task that updates each knowledge source during the training and testing on all knowledge sources. And Table 5 is the same experiment evaluated by each knowledge source. Table 6 shows the results if we use the same knowledge source for both training and testing. Here, the trained models are the same, except we also update the knowledge sources updated during the training for testing as well. We did a similar ablation on dialogue response generation as well. Throughout the experiments, we found that the selection quality of the knowledge really matters. Dialogue generation with gold knowledge significantly outperformed using retrieved knowledge. And as Table 4 and all other tables show that the performance varies across different knowledge sources. Moreover, the larger ablated training knowledge source is, the worse the test performance becomes. For example, OPIEC consists of the majority of the knowledge tuples. Therefore, when OPIEC is ablated during the training, the F1 performance of the test performance decreases the most. On the other hand, Wikipedia is not the case. That's because Wikipedia is already included in the pre-training of both Roberta-based model and the BART-based model. Most interestingly, during zero-shot adaptation, including more knowledge inputs improves the performance. This is similar to the in-context learning. For example, as the colored box shows that almost every entries in Table 5 outperforms Table 6. Finally, we found that both small language models and large language models, such as BART and Vicuna, show similar trends as we observed before. Specifically, LLM-based response generation task can be considered as an extreme scenario of zero-shot prediction, where no in-domain training is conducted at all, compared to the fine-tuned models, which have the opportunity to learn the speaking style and the statistical distribution of the conversationalists. The Vicuna-generated zero-shot responses are significantly longer. The Vicuna-generated outputs have less overlap with the corresponding gold responses, but higher unigram overlap with the input knowledge in the full knowledge setting, indicating that the LLM is able to generate utterances relevant to the input knowledge when the sufficient knowledge is given. Surprisingly, when provided with gold knowledge only, the LLM seemed not to use the provided knowledge to the same extent, and we see a decrease in the performance in contrast to the BART-based model that improved with gold knowledge. However, similar to the BART-based models, we still observe that more knowledge sources provided at the test time significantly improve the LLM's performance, response generation performance across all metrics. This work shows that how the model behavioral changes as we vary the inputs in a retrieval-augmented generation-like setting. As a conclusion, obviously, training models on knowledge-intensive inputs help a lot. And meanwhile, simply adding more knowledge during the inference also helps. As a conclusion, in this work, we introduced the MIS-WOW dataset of multi-source support knowledge for open domain dialogue generation, with knowledge tuples partitioned into disjoint sources and grounded at the utterance level. We further introduced the dialogue knowledge plug-and-play challenge, where a trained dialogue system must adapt to a new knowledge source at a test time. Our baseline experiments demonstrate how future works can use MIS-WOW to study how dialogue models generalize to new knowledge sources.